Have you ever just stared at a problem, I don't know, a gadget that's on the fritz, or a recipe that completely bombed, and you had no idea where to even start? Well, what if I told you there's a powerful framework for your brain, a kind of secret weapon for thinking clearly? And no, it's not just for science labs with bubbling beakers. It's a tool you can use to solve problems, big and small, every single day.
So, to really see how this works, we're going to start with a puzzle, a little mystery. Let's call it the Candy Conundrum.
Take a look at this. These are all the real pieces of an experiment a teacher named Mrs. LP actually did. It involves 7th graders, starbursts, and running a mile. But right now, it's a total mess. It's like someone took the entire science report, tossed it in a blender, and just dumped it on the page. You can't tell what happened or why.
So the big question is, right, how do we get from this jumbled up pile of information to a clear answer? How do we find the actual story that's hiding in all this data? Well, it turns out there is a method to the madness.
And that method is the scientific method. It's not as scary as it sounds, I promise. It's basically just a structured way of thinking that acts like a roadmap, guiding us from a confusing question all the way to a clear conclusion.
And here is that roadmap. It's pretty simple, really. It starts with asking a question, then you make a guess, you test that guess, see what happens, and finally you figure out what it all means. This is the exact toolkit we're going to use to solve our Candy Conundrum.
But really, don't let the name fool you. This isn't some super rigid, complicated thing only for people in white lab coats. It's actually a natural way our brains are already wired to solve problems, whether you're in a science class or just trying to figure out why your Wi-Fi keeps cutting out.
Okay, so let's put this toolkit to the test. We're going to grab that jumbled up experiment and use these 5 steps to bring some serious order to the chaos. So it all started with a simple bit of curiosity. A teacher, Mrs. LP, just wondered, could feeding Starburst candy to her 7th graders actually help them run a faster mile?
And boom, right there. That's it. That simple question is the crucial first step of the scientific method, stating the problem. It's the starting line for any investigation. It defines exactly what you're trying to figure out.
Now, Mrs. LP didn't just stop with the question. She made a prediction. She thought, okay, Starbursts are basically pure sugar. Sugar gives you energy, so they'll probably give the kids a quick energy boost and help them run faster. Makes sense, right?
And that prediction? That's our second step, the hypothesis. Notice it's an educated guess. It's based on something she already knew, that sugar provides energy. It's often written out in this if-then-because format. So for her, it would be, if students eat Starbursts, then they will run faster, because sugar provides a quick burst of energy. See how that works?
All right, so with a question and a prediction, it was time to test it out. Mrs. LP designed a really simple but smart experiment. She got 8 students. 4 of them got 3 Starbursts each. The other 4 got nothing. Then they all headed to the track and ran a mile, all at the same time.
And this test she put together? Well, that's our step 3, experimentation. This is the action phase. It's where you follow a clear set of steps to see if your guess, your hypothesis, actually holds up in the real world.
So what happened? Here's the raw data she collected. You can see the times for the kids who ate the Starbursts on the left and the times for the kids who didn't on the right. Just a quick glance and you see something kind of surprising. The fastest times. Look at that, 6:08, 6:30. They're all in the no Starburst group. Interesting.
This raw, unbiased info, these numbers, this is our evidence. In scientific terms, these are our observations. That's step 4. This isn't about what we thought would happen. It's about what actually happened. These facts are going to lead us right to the answer.
So when Mrs. LP actually looked at her observations, the evidence was crystal clear. Her hypothesis was wrong. The results showed that feeding Starburst to 7th graders did not help them run the mile faster. In fact, the data kind of suggested the opposite.
And that brings us to our final step, the grand finale, the conclusion. This is where you analyze your data, you say flat out whether your hypothesis was right or wrong, and you finally answer your original question based on the evidence you just gathered.
So, we've got our answer. Starbursts don't help. Case closed, right? Well, not exactly. A huge part of thinking like a scientist is realizing that every answer just leads to more questions. For instance, was this even a perfect experiment?
You see, good science means thinking critically, even about your own work.
You have to consider what we call sources of error, all the little things that might have messed with the results. I mean, what did the kids eat for breakfast that day? Were some of them already on the track team? What about their shoes? All of these are variables that could have changed the outcome.
And this is one of the coolest parts of the whole process. Every experiment can spark a bunch of nuance. We call these lab extensions. The Starburst experiment might make you wonder, hey, what about chocolate? Or what if they ran in the afternoon instead of the morning? Does sugar help with brainy stuff like getting a better score on a quiz? Every one of those questions is a brand new experiment just waiting to happen.
Okay, so now that we've unscrambled the whole candy conundrum, let's bring this method right back to where we started, your everyday life, because this exact same structured thinking can solve problems right there in your own kitchen or garage.
Seriously, think about it. Ever baked a cake and had it just totally sink in the middle? Your question is, why did my cake flop? Your hypothesis might be, if I open the oven door too early, then the cake will sink. So you run an experiment. You bake another one, but this time you don't peak. Or what about trying a new food like capers? The experiment is tasting one. Your observation is the flavor, and your conclusion is either a yes or a definite no. You see, you're already a scientist, and you probably didn't even know it.
So, thinking like a scientist isn't about knowing all the answers. Not at all. It's about having a really great system for finding them. It gives you the power to turn chaos into clarity and your own curiosity into real knowledge. So now that you have the roadmap, what question are you going to try to answer first?